Let's take a look at this application to economics. The graph in the figure approximates the rate of change of the price of eggs over a 70-month period, where E of t is the price of a dozen eggs in dollars, and t is the time in months. Determine when the price of eggs was rising or falling, and sketch a possible graph of E of t. So this is the graph given between 0 and 70 and negative 0.03 and 0.015. Note, this is the graph of the derivative of E of t. Really important to understand this. Why? Because you were told in the problem that the graph gives you the rate of change of the price of x. Okay, it doesn't give you the price of x itself, it gives you the rate of change, the derivative. So with that in mind, we take a look at what's happening for t less than 10, and 10 happens to be right here on this graph. And what you'll notice is that e prime of t is negative, so E of t is decreasing. Okay, that's when t is less than 10. So why is e prime of t, oops, I'm sorry, I have the wrong point here. Be careful and don't do what I just did. This is 10. T equals to 10 is right there. I'm sorry. With that in mind, we notice the derivative is negative because it's below the x-axis, right? All these points here are below the x-axis. In this case, actually, the t-axis. Therefore, if the derivative is negative, we know the function itself is decreasing. So E of t is decreasing. E prime of t changes sign from negative to positive at 10, right? Because right after 10, the derivative here is positive. Notice it's above the x-axis, this graph. Okay? So that means at t equals to 10, we have a local minimum, because the function goes from decreasing to increasing. In other words, the derivative goes from negative to positive. Well, this price happened to increase for the next 40 months until it hits 50, right? So this would be right over here. And the derivative keeps being positive. That's what we mean. So the number of eggs keeps increasing. The price of the eggs keeps increasing, not the number of eggs. So the price then increases for the next 40 months to a local max at 50. Why is that a local max? Well, this here is a local max because the derivative goes from positive to negative at 50. So the function goes from increasing to decreasing. It's hard looking at the graph of the derivative to realize that the graph is really, of the function, is really increasing between 10 and 50. But remember, this is the graph of the derivative, e prime of t. It is not the graph of the function itself. So to the right here, we have a possible graph of our function e of t. So to summarize this section, we have examined where functions are increasing or decreasing, how to find critical values, the existence of local extrema, we learned about the first derivative test, and we did some applications. Make sure to read this section carefully. It is an important section with a lot of important insight about the rest of the chapter and the course. So please make sure you understand everything in it and ask questions on the discussion board if you don't.